Okay, hello everybody. My name is Vladimir Neikov. I'm a professor at Mechanical Engineering Technology program. I'd like to give you a brief description of what is Mechanical Engineering Technology program. It's established back in 70s at a time when the university and the college was together. So a group of enthusiasts make the civil engineering and mechanical engineering program working together. And then later on that was a separate mechanical technology program, which was now separate in a technology group. I'm first time using Zoom, so please forgive me. It's a little bit stressful for me, and it's, I don't know, it's not working. Okay, finally. So what is a mechanical engineering? It's working with mechanical equipment, devices, machines, anything that moves, it's considered mechanical. So what are the typical jobs that students can get after graduation? It's working in a design field, doing a drafting, prototyping, prototype testing, building projects, learning machining, so how to use machines and work with the equipment, heating, ventilation, air conditioning. Also, our students learn about production management, quality control, consulting, material testing, modifying existing equipment, improving it, maintaining some technical cells as well can be learned. What is required to get into the program? So that's grade 12 requirement with minimum 60% in pre-calculus. So equivalent of the pre-calculus could be a grade 12 pre-calculus, principles of math 12, adult basic education, Okanagan College, math 120 course, physics 11, English 12. It's also recommendable to have under the belt at least chemical 11 or chemical 12. It's not mandatory, but it's a great benefit if a student will have these courses done. We do a lot of teaching engineering materials which are based on some knowledge from chemistry, fluid mechanics that again uses some of the concepts in chemistry. So that's something that is beneficial if the students can have these requirements. So what are the typical jobs that can graduates go and after they finish the school? So here is some of the companies that worked closely with Okanagan College. Some of these companies offer COPE, and our COPE students work between semester 2 and semester 3 for 8 months as a trainee, and they can learn what's the requirements and what is needed to become a good technologist in this company. They learn a lot, and every time our students come back from a COPE program, they say, yeah, we learn a lot. We've seen all this stuff that you guys are teaching us, apply it in real life. So it's highly recommendable to go through that program. Um, uh, it's 8 months after semester 2. Uh, Once you finish semester 2, you go to the 8-month COPE. You come back in semester 3 in January next year. And after semester 3, another 4 months COPE. So that's COPE part 3. And you go for the last semester in September, semester 4, and then you graduate. During the COPE, usually they establish their relationship with the company. If the company likes our students, they go and continue their work after graduation. So it's a good opportunity not only to get experience, get a good resume, but also establish good connections with this company and work after graduation. Some other career paths that are possible. So that's CAD/CAM. So we extensively teach our students in CAD modeling. Abbreviation CAD stands for Computer Assisted Design, and CAM stands for Computer Assisted Manufacturing. So the major softwares that we teach students are SolidWorks, a little bit of Inventor, extensively AutoCAD. AutoCAD is used also, but primarily it's three solid modeling software called SolidWorks. It's now it's a standard. It's a requirement in industry to use that software, and students like it, and they found it very beneficial, very productive to work with SolidWorks. For the CAM, we use MasterCam, which is, again, it's a standard in industry. It's used for programming the computer numeric control machines, or called CNC machines. And the CAM software generates a G code that you upload in the machine, and the machine does the work for you. Others are design. So our students will study statics, then we'll study dynamics, and they'll study engineering principles, machine design. So that is applied in industry, and help them work and perform tasks as a designer. Our students also study a little bit about project management, operations management, so they get some production and planning skills, working with people on the floor and supervising them, quality control and assurance. Also consulting and installation maintenance for process plant machinery, HVAC systems that are typical for this kind of jobs. Technical sales, customer service support, also it's a good career path. After graduations, our students work in the industry, and they can register as applied science technologist and technician in BC as TTBC, and they can become members. It's beneficial for them. Most of the companies are looking for registered technologists with ASTBC. Registration can be while you're still studying in a college for free. And every year we have a representative from ASTBC coming to our class and talking about benefits. Why is that important to be a registered technologist and working? So for us, for example, I'm a professional engineer, and I'm registered with Engineers in Geoscience BC. So it's the similar organization for technologists. Also, students can continue study and become a mechanical engineer after 4 years of study, and 4 years study and 4 years relevant work in industry as engineer. They can become registered professional engineer and work on a higher level of science. So at this point, I would like to explain what is the difference between technician, technologist, and engineer. Technician requires 1 year of training, and mostly it's a tasks performer type of people that certain tasks and drawings and documentation will be given to them, and they go and execute it. Technologist is a person in between technician and machines. So she has a complexity of skills like understanding designing concept, and at the same time understand uh, how to machine and fabricate. So he's the link between these two groups of people. And also technologists can be a supervisor of group of people. So that's why we train them in manufacturing and production operations as well. Engineers are mostly science and design and not so much related to industry and production. They are mostly performing complex calculations, statistics, do statistic analysis, testing, performing questions that require synthesis, analysis, and high level. And mostly they're graduates from university 4 years. So technologists will need 2 years of training, engineer will need 4 years of training. Following our program, it's outlined here. So first of all, I want to say that's a nationally accredited program by TAC. TAC means Technology Accreditation Committee. Were certified a few years ago, and previously it was CTAC, different accreditation committee. So we're almost 10 years of experience with accreditation. What does it mean? That means if you graduated here in the Okanagan College, anywhere in the province, anywhere in Canada, your degree will be recognized. You don't have to take any extra exams and any extra study to be able to work as a technologist. So that's the benefit of, and I would say strongest benefit of our program. It's nationally accredited. And most of our graduates go in different provinces and find jobs, and they are successful. So the outline of the program is shown here. It's semester 1 begins at September. By Christmas, semester 1 is accomplished. There is 7 courses that need to be taken. Engineering graphics, that's drawings, learn how to use drawings, materials, statics, engineering principles, fabrication, communications, that's English, math, so that's one of the courses that is in this program. There's 2 actually. The second math is in the second semester. Then semester 2 starts in January and finishes in April. And then the next level of courses is taught. They are fundamental. So both semester 1 and semester 2 are fundamental theory courses. Upon graduation of finishing of these 2 semesters, students go on COLP term, May to August, and then September to December. So COLP 1 and 2, I already talked about that. It's very beneficial. Students are placed in industry. Our COLP office is doing a great job finding jobs for the students and placing them. Then in January the following year, they will come back for semester 3. And they study now higher level courses like machine design, thermodynamics, hydraulics and pneumatics. This one is a very strong program that our students benefit a lot. Uh, then automation, electronics, and they go again for a 4-month program. And come back in September the same year for the final set of courses, capstone project, operations management, thermodynamics, application of thermodynamics, which is actually heating, ventilation, and air conditioning, robotics, computer assisted manufacturing, aided manufacturing, sorry. So that's computer machining. So they learn how to work and operate a CNC machine and doing the projects on the CNC machine, which is amazing. It's very interesting how to learn that. And the second electronics course. So our program has a bridging, which is established approximately 5 years ago with the UBC Kelowna. I was involved in that process, and I would say this bridging program now works successfully. Every year we sending to the UBCO anywhere between 3 and 5 to 8 students for bridging. The benefit is after they go through the bridging program, which is only 4 courses, they go directly second year, second semester at UBCO, which is saves them a lot of tuition, a lot of study. So the courses that are offered by our program are satisfactory to waive the first year and go directly second year, second semester at UBCO. Also, we have established previous years with UBC Vancouver, Victoria, Lakehead University in Ontario. It's long relationships with these universities. Bridging program, as I mentioned, requires 4 courses. That's Calculus 3, which soon will be reduced to Calculus 2. There's certain agreement now that if I believe the new graduates that will come to our program will be required to take Calculus 2, because Calculus 3 is taught in UBCO. University English, chemistry, and materials. So that's the 4 courses that they need to take before they enter university. What our students study in our program? So that's samples of work to get an idea what actually is. So in the CAD, we teach them first semester AutoCAD. I'm instructor for this course. We teach them basic orthographic projectioning of parts, applying all the manufacturing concepts and symbols and stuff that is necessary to produce a good quality drawing. 3D modeling, which you see on the right hand side, so using for that SolidWorks and Inventor. We used to teach Pro-E, but industry doesn't require it anymore, but we still have a capacity to do that. Designs, all of the courses that are related to design, like statics, dynamics, machine design, all that involves fluid mechanics and hydraulics later. So you see on that photo a hydraulic bench on the back. It's in our machine shop that you can actually simulate hydraulic equipment and connect hoses and gadgets and connectors and switches, and you can actually make it work. It's a fun course to study and to work with the equipment. I also teach engineering materials, so anywhere from recognition of different materials, carbon iron diagram, heat treatment. Especially I put a emphasis on the heat treatment of the materials, which is essential for the technologists to understand how the material can be modified by treating with heat, quenching, tempering, normalizing, and etc. All these kind of interesting things. Automation, CAD/CAM systems. We have one course for industrial automation, like conveyor systems, packaging systems that our local industry requires. CNC programming, that's a photo of CNC machine in action. We also teach our students to program robots and give them specific tasks for, let's say, transportation, packaging, and different kind of task that a robot can do. Some of the samples of design projects, there's lots of them. Lately we are using a 3D printing for capstone projects, so students actually print little samples, assemble them, and they look at the functionality and parts. This photos previous year's project of done by students. Here is another example of our graduate that works in Alpine, Kelowna, West Kelowna. So he's involved in rebuilding helicopters and refurbishing them. So our students study hard, they play hard, they graduate and then go out and make some noise. And they're very successful. You can explore our website, you can ask questions. I would suggest go to our website and see mechanical engineering program, what is there, and feel free to apply. It's an interesting, cool program to work and study, and thank you for your attention. So I just want to tell you that there is $5,000 tuition credit. You can go on this website and tuition giveaway and apply there. You might win some tuition waiver or some money for tuition. All right, are there any questions? Yeah, Ryan, go ahead.
Yeah, I'm just curious who I'd be able to talk to about the minimum requirements for a laptop or like a computer for mechanical engineering to like run
Yes.
SolidWorks and CAD.
Yeah. I can give some basic information, even though I'm not a computer specialist. IT department is excellent for that job, but I think probably a regular laptop that you can find in the stores with enough hard drive space probably would require probably minimum 500 giga. Will be good. RAM memory about 16 giga will be sufficient. A diagonal of the screen usually is bigger than 14, 16 inches. I'm just throwing numbers. I'm not sure about the actual size, but that's something that is pretty good. i7 Intel 4-core would be good. So I think that's pretty sufficient for that. But more details, you can go on the website of SolidWorks, and they have a special list of exact requirements of what you need to do to install SolidWorks.
Okay, thank you.
Answer the question. Yeah, you're welcome. Okay, are there any other questions? Okay, then thank you for attending, and spending time to see and learn about the mechanical technology program. Think about joining it.